if more people show up, they'll just have to come in a little late. So today we're going to be talking about React, which is probably one of my favorite frameworks. Uh, Basically, it's used for making bigger, badder websites, but easier and more organized than you'd normally just write HTML and CSS and JavaScript. So let's start from the beginning. Everyone knows vanilla JavaScript. Everyone's taken Web App 1. You got your document.element by IDs and your event listeners for clicking and pressing keys on your keyboard. But this is very verbose, and no one likes writing all this, and it's very hard to maintain if you have a lot of code. So collectively, we came up with jQuery, which is essentially the same thing, just kind of minified a little bit. It can do some extra things that vanilla JavaScript couldn't do by default. You'd have to build it yourself, but jQuery includes those functions, somewhat like this document.onClick function. Basically, it just made everything easier in the world of web programming. But even then, jQuery was still hard to maintain. So we decided to innovate again. And we thought we could do a lot better. So we came up with a new web programming paradigm. And this is probably like 7 years ago when this type of paradigm was started to be used in the web. So we thought, what if we could start using modular, reusable components to build declarative web apps? So we tell it exactly what we want it to do. We don't have to worry about the quirks of JavaScript and the quirks of CSS. It's repeatable and predictable. This is where React comes in. React is component based, so all of the parts of the UI that you build, like if you make a button, you can reuse that button somewhere else and you don't just have to copy paste code. So if there's a problem with that button, you don't have to go fix it everywhere. You can fix it in one spot, which is the great benefit of being component based. It's declarative, so it'll do exactly what you tell it to every time. Predictable essentially means that too. And it's reactive, so when you change something, the UI will update automatically instead of you changing some variable in JavaScript and then having to do a document.element by ID and write the inner HTML or whatever like you used to have to do with jQuery and vanilla JavaScript. It will just change when you change something. And it's testable, so you can write what we like to call end-to-end tests. So if I click some button, is the proper elements shown or the proper page shown? That's really easy to do in React because you can test the components individually. And so if all of the components work correctly, then your entire UI will work correctly. So it's a great way to get things organized. Now, first thing to understand is React is not stack dependent. So React can actually be used other than the web. React DOM is the actual thing that links it to the web. React is just a way of organizing the hierarchy of how things are shown on the page. And then React DOM is the thing that actually takes that and turns it into the DOM, the document object model that browsers use. And there are other renderers that you can use, such as React Native, which is gaining a lot of popularity these days. And there's a renderer called Ink, which lets you render terminal applications using React, which is it's pretty cool. I've worked with it a tiny bit, but I haven't seen anything too big built with it yet. And those work as just drop-in replacements. You would just change your like one line of code to change which renderer you're using. So first we need to understand the document object model before we can understand what React does and what makes it so great. So the document object model is the way that the browser keeps track of how the page looks in the backend. So, when you write a web app, you have, your paragraph tags and your div tags and your H1s. These are all DOM nodes. And then the DOM is a tree of these DOM nodes. And then when you would click an element, it would run, the click function on that element, and it would kind of bubble up through the tree until it hits something that's listening for that event. And so the browser keeps track of all of that at the same time. So what React does is it introduces the virtual DOM. It's just like the DOM, except it's virtual and not rendered. So you don't ever see the virtual DOM. And it manages this at the same time as the browser managing the DOM. So you actually have two DOMs when you're using React. And the reason why React does this is because if you make a change to something in the DOM, you don't know what all has to be re-rendered, and the browser just gets to do it itself, which isn't particularly fast. And so what React does is it first commits the changes to the virtual DOM, and then it will figure out which elements have changed, which components have changed, and then it will only update those in the real DOM. So it does all of its processing virtually, so it only ships over its updates to the real DOM when it's done processing. And like I said, this makes for snappy changes. It's still not going to be faster than vanilla JavaScript. React doesn't claim to be. But when you have something that is as nice and big of a framework as React, having it be as snappy as it can is obviously a priority. So it only updates things that need to be updated, like I said. Now, here's some React code. It looks really annoying to write. And this is the first generation. This was 7-8 years ago. So you just essentially write it kind of like HTML, except you're doing it in JavaScript. So, create a div element, create an H1 element, and put the text hello world in it. And then, like I said, React DOM is the actual thing that renders it to the browser. So this code would kick out something like this on the page. Pretty simple stuff, but like I said, this code isn't very nice, not easy to read. So, oh, are you guys watching on the YouTube stream? I forgot that I wasn't screen sharing. Okay. Let me go back over here. Okay, I'll just quick run through these things quick. Okay. Someone should have said sooner. Yeah, okay, I'm streaming my screen. Okay. Like I said, vanilla JavaScript, equivalent jQuery. I run over here. Stuff I said about React. The code is really the only part you need to see here. This is what React code originally looked like when it was first released 7-8 years ago. And this is the equivalent DOM tree that it creates. Okay, now we should be caught up again. So this is where JSX comes in, which stands for JavaScript XML. It allows you to write XML, which HTML is a subset of, in JavaScript at the same time. Now your browser can't run this code. It actually has to transform this code into JavaScript. So it actually translates what this looks like into the old style of React. So technically it's not old style because it's still used. You just don't write it. It gets transpiled into instead of written directly. So yeah, it's a superset of JavaScript. Any JavaScript is valid JSX. You could copy paste any JavaScript file and put an X on the end of the file name and it would be fine. It just allows you to also write XML. So before we finally get into actually making components, we need to look at the component lifecycle. Ooh, my screen is very white right now. Okay, here we go. So our components, but when we would create those components before, here, let me go back and open this in a new tab. There we go. So when we would create these components here, React does a couple methods on them before it actually renders them into the browser. So when it first sees this element, it's going to call this constructor here. And it's going to actually mount that element, or it's going to attempt to mount that element into the DOM. Mounting is when it takes it from just being in the virtual DOM for the first time and putting it in the browser. So first it runs the constructor, then it runs your render function, which these are automatically defined for the base HTML elements. And then after that, it does a couple extra things, and if you need to know more, you can click this button here and see a couple extra functions that it runs, but the simple explanation is good enough for us. And then when it's done mounting, it runs this function here, which we'll see again later on, which just is React telling you that it actually mounted it into the browser. And then after that, every time React does an update, which, like I said, it only does updates if this specific component had something that changed that needs it to update. It will call that render function again, and again call a nice helper function that will help you if you need to calculate like styles and stuff. This is a good spot to do it in. And then similarly, when a component is no longer needed, it'll just unmount, similar to mounting, just the opposite. So the general life cycle is you call constructor, render, mount, and then every time it updates, it renders again, calls this function, and unmounting it lets you know before it does in case you need to clean something up. So now we can actually look at what we can do with more than just basic HTML elements. And that is the custom class components. So we're defining our own class here, which extends a built-in React component thing, which all of the basic HTML elements essentially do the same thing. They just have more methods defined here. And this part isn't necessary if this is all you're going to have in the constructor, but it's nice to know that this is here, and this is the same constructor that we just saw in the component lifecycle page. And this is the same render function. So this hello world example here is the same one that was shown earlier using vanilla JavaScript and jQuery. And it looks a bit more complicated, and while it is for very, very small components, when you get a lot bigger, it makes a lot more sense. So you can see down here, we just render this, and we can use our class directly in JSX syntax like we would use a div or an h1, because it counts this as a pseudo HTML element that it can render. So let's build up a simple example together that shows something a little bit more complex than just hello world. So we're gonna create a counter that just counts up 1 every second. So we're gonna start out with the most basic React component. What it does is render 0 in an h1 tag. And then we're going to include our constructor, and this is where we first set our what we call state variables. So obviously if we want the number in the h1 to change, we have to have some JavaScript variable for it. And so in class components, we do this using this special this.state object, in which we can define anything, any normal JavaScript variables here. And then anytime something in here is updated, this component will recall this function. And so anytime this count would change, state would change, then React would cause a re-render. And this.state.count, which is obviously this variable right here, would get the new number, and then it would render with the new number here. And you notice I use these curly braces, which is the JSX way of saying inside of here is an HTML block because I use tags, but then once I open curly braces, it knows to go back to a JavaScript block. So this in here is normal JavaScript, and I could keep nesting these. You can nest them as much as you want, which is actually a very useful thing because you will nest a bunch of times if you're writing a bigger project. But basically the thing here to know is that this will re-render every time this.state changes. And so now we have to actually change this.state. So we use that component did mount function that we saw earlier. So this is run after it's initially put into the DOM. And we just do a default JavaScript set interval every second, every 1000 milliseconds. And then the other special function here is this.setState. So we can't just change this directly. We have to use the this.setState function, which we just pass it an object that looks exactly like this. So this is the same object, except we take our previous value, add 1 to it. So every time this runs, it's going to get the value, add 1, put it back in. And like I said, every time it runs this function, it'll cause a re-render. So you can kind of see how it starts to flow through the component. Every time this gets called, it'll re-render this. And this is really all that you need to get a counter working. So if we were to throw this in a React like project, this would just straight up work right now. And then a reason why we have to do this function instead of putting it directly into the constructor, because you'd intuitively think, well, as soon as my thing gets constructed, I'd like to start the set interval. But it runs this before it puts it into the browser. So functions like set interval or like the document object aren't defined yet for this component. So you couldn't do like document.addEventListen or something. That just wouldn't work because the document object doesn't exist. But it's guaranteed to exist when this function runs, which is why it's okay to put functions like this inside of here. Now, another thing you would want to consider if you were making a component like this, even if this component leaves and you're rendering something else, this interval will still exist. So you'd have to use the component will unmount that I was showing before when your component would unmount to clear the interval. Otherwise, React will throw you a nasty error. But that's beyond what we need this for, just to show a simple example. And like I said, that's it, a fully functional reactive counter. We don't need really any boilerplate code, and that's a full component. Now we're going to move into what we call modern React. So class components aren't really used anymore because you saw even for printing hello world, it was kind of a lot of code, and we like writing as little code as possible. So this is when we came up with functional components, which is, this is essentially the same thing, except it's just a function that returns some HTML-like object. And this function actually gets run every time this element is rendered. So we no longer use the same component lifecycle. We still use it under the hood, and you'll see why on the next slide, but you can see this is obviously a lot less code and much closer to what we were doing in vanilla JavaScript and jQuery. And again, we just render it the same exact way. And the reason why there's a slash and a empty thing is here is because if you have an empty HTML tag, you don't need both tags. You just do one and then a slash before the closing chevron. So this is where hooks come into play. So we didn't want to have to use this.state and this.setState because that state object can get pretty large and it's going against the grain of what React tries to do, which is make things more organized and not a pain to maintain. So we introduced hooks. Hooks always start with the word use. That's how React knows that it's a hook. And it comes with a couple ones enabled by default, which the two big ones that you would need to know is use state and use effect. So use state is essentially this dot state that we were using before and this dot set state combined. And the good part about it is that you can use multiple of these in a single component. And you'll see why when we start looking at examples for this. And then use effect is essentially all of those same functions that we had before that had really long names that I never remember, and combines them all into one function that you'd think would be less controllable, but is actually more so, in my opinion, because it can do all of the stuff that these can and more, and much more succinctly and cleaner. So, like I said, you can't use lifecycle methods and functional components together. They just don't work. Lifecycle methods are for class components, and hooks are for functional components, as we call them, because they're just functions. So, we're going to build the same counter example, but with functional components. So, again, we start off with just turning H1 with 0 in it. It's a lot cleaner this time. Oh, I meant to go down. And now is where we introduce a hook. So before, when we introduced count, we did this state equals some object with count in it. Now we just set some variable count, and this is JavaScript destructuring. UseState actually returns an array with the first value being the state, so we can take that out of the array by doing this. And then we use the useState hook here and initialize it with the value of 0. So this is essentially what we did before, where we just set count to 0 directly, and we're rendering count here. And notice that we don't need like this dot state dot count. We can just do straight count here because it references this variable exactly. And now here's where we have to introduce a little bit more complexity. So, like I said, this returns an array, the first one being the actual value of the state, and the second one being a function that lets you set the value of the state, or update the value of the state. So in this case, we name it like this, but these could actually be named anything you want. This is just the React way to do it. It's the generally accepted way. So if we were to call set count, what it actually does is updates this count variable, and then it will cause a re-render, which is this entire thing is essentially the render function. And inside of it, we use things like useEffect to abstract things out of being only in the render function. And I'll talk about that in a second, but basically every time this is rendered, it will grab this count variable. And even though we're calling useState here inside of the function, React actually saves the value of this state. So when it runs this function again, it will still have the same count value that it had on the last re-render. So this is essentially like a persistent variable across multiple runs of this function. And then we move on to useEffect, which, like I said, is very similar to component didMount. We just use a function and we pass it what's called an anonymous function or closure as an argument, which is just some code that we want it to run. So this is just a function body in here. You could abstract a function outside of this component and pass the function into here. That doesn't really matter. And again, we just use that same set interval, but you notice this is a lot cleaner because we don't have to do this dot set state count equals this dot state dot count plus 1, because we can just reference these values directly. And the same thing will happen. This set count causes a re-render, causes this count to update, and this is almost exactly equivalent to the class component that we just made. You'll notice it's a lot shorter. When React moved to this functional pattern for creating components, and people started migrating to it, it reduced the size of their React project code bases by, I think, average of like 40%, which is a very substantial decrease in size. So the last big point about React is that it's distributable. So this counter component that I wrote here would work on my React project, it would work on your React project, it would work anywhere that React is used. So what people have taken to doing is creating component kits, which are essentially a big amount of components that have been pre-styled and already have like JavaScript for animations and all that stuff pre-built into the component. And you can just take that, put it in your project, and just use it directly. No like big setup or anything. And React just knows how to handle that. So some of the big ones, design libraries are a big one. So like all of the things that you see here, like this button is probably a component. You know, this like white box here, this modal, probably a component. And so this shards library lets you use all of these components, and you just include them directly. And when React actually builds your project for the web, it only includes the like pieces of components that you use, because while React is pretty heavy as a framework, it can do some nice optimizations by only including the parts of other projects that you use. So like if I was using shards and I just wanted this button, I could use just this button and not worry about having to bring this whole library with me. Because bundle size does get to be kind of a problem. So when React compiles, like I said, it has to transpile your JSX into real JavaScript, and then it minifies everything, and then it has to ship the entire React runtime, which is quite heavy. But it uses a lot of caching. So once you load it once, it's stored in your browser. So next time you go to that website, it'll grab it from your browser instead of from the server again. And so people always list size because that actually matters. You don't want your bundle to be too big. Another good one is Argon. I've actually used this one for a couple projects, and this is just, the UI elements you see here, like buttons and picture, navbar. All that stuff is part of the component kit, and you can just take their components and build them up in any way that you want. If you want a bigger list, if you go to this presentation, and look at this GitHub repo right here, there is a list of like probably hundreds of React components. So you see there's stuff for everything, a carousel, device input, grids, tables, like there's a lot of React components that people have built for you. So you don't need to make a bunch of stuff by hand. Like we've had to use color picker before, and so you can just go look up React color picker and find one that works for you and just use it. So that really accelerates the speed at which you can do development. So our website, I don't know if we've said this previously, but our own Programming Club website is written in React. We use React and Firebase, both things that we've talked about this year. And here is just, this was the shortest file I could find on our website. I don't know why this little snip is here, ignore that. But this is, the shortest one I could find on our website. It's just a spinner, so when something's loading, it shows you a little spinner. And we use this in multiple places. Like I said, it's reusable. Doesn't matter where you use it. And we're using a component kit like we just talked about. Or we use RSuite is what ours is called. So we just take their loader, build it into a component for us, and use it directly on our website, which you'll see if you go to our meetings page or resources page. Does anyone have any questions before I move into an example? I'm going to take that as a no. So I'm just going to create a quick React project so you can see how easy it is to get something up and running. Now you can use things like Yarn or NPM. I prefer Yarn because it's faster. It's multi-threaded when it gets packages. That's really the only difference. So there are a couple of utilities that React provides. We're going to use something called create React app. So we're going to go yarn create React app and we're going to call it counter. And so this is going to set up the project for me, download all the packages I need, and set up just a couple like template files that I can edit really easily. This does take a second. You see some of the stuff we've talked about here. There's React DOM and React. And React scripts is just the thing that handles like building your application for deployment and doing like a dev live server that changes when you update. It should hopefully be done here soon. And you can use React with TypeScript that we talked about, I think, a couple meetings ago. That's generally the pattern that I prefer because having types clearly defined is quite nice. Wonder why this is taking so long to finish. Let's see if I can. Uh, it looks like it did finish. It's just confused. Okay, yeah, I was just confused. That was weird. Okay, let me go to that directory, open up VS Code, and if you do development in React, I would heavily recommend VS Code. It's just got the best tooling and extensions, so you'll have to go here and if you want syntax highlighting, look up Babel. Gives you great syntax highlighting. There's React snippet libraries and autocorrect. There's plenty of tools to help you build apps with React. So we are going to, oh, you can't see it? Oh yeah, here, I'll fix that real quick. There we go, okay. Yeah, so I was just saying that there's plenty of extensions. There's thousands. Okay, so we're going to delete all the files we don't need. It comes predefined with like tests and stuff, which we don't care about tests for a small project. And there we go. So notice we have this index file, which has that same render function that we saw on the slides. And you can kind of ignore these. This is just a React thing that it likes to do. And you see we're rendering this app component, which comes from this file here, app. If we go over to that file, you can see we define our app here, and we do it in the functional style because that's what React likes to do, and we can shorten this way down to just say hello world. And let's delete that because it's not defined. That's also not defined. And now we're kind of basically back to where we were on the slides. And now we can, I'll start in here. We just do yarn start. You'll see it's starting the development server. And it opened on my other monitor. And here's our React app right here. And so if we just make this smaller and we change something here and save, you'll see React updates automatically. So this development server is actually live, and you can edit even the stuff in the HTML live, and it will update here pretty quickly. So now we're going to just make a simple counter like we showed in the slides. So make a counter file. Normally you declare things in different files just so you can keep stuff organized. And you capitalize the name of components as a general convention. We're just going to go to exactly what we had before. And since we're using multiple files, we have to actually export things. And then we'll just import it in here. And you don't have to put the file extension for JavaScript names or for JavaScript files. And now instead of rendering this, we're just going to render our counter, which when we save this here, see it just renders 0. So we have our counter running. I'll move this over here a little bit. And now we're going to set up the state like we did before. So I didn't show the import statements, but you do need to use import statements. So we'll use state from React and type exactly what we had on the slides. So count, use state. I'll make this window a little bit bigger. There we go. And my editor's already yelling at me because I haven't given it a value, but I can just calm down for a second. So if we save this, nothing happens because it's rendering the exact same thing. We just changed it to use a state variable instead. We need to include the other function we were talking about, which is useEffect, and get the other part of this array that's returned. Like I said, you can name this literally anything. It doesn't matter. So just the exact same function we had before, and you have to include this array here. If you don't, you'll have many problems. We've run into that before and didn't know what it was until we figured out that it was this array, and I'll talk about what that means in a second here. But we're just gonna put in our set interval and set it exactly like we did before, set count plus 1, and give it a 1000 millisecond interval. And now if we just save this, see over here it's counting up. Well, it should be at least. I think it might have run into an error. I think it just got confused. Either way, this should work. And what this array here is it says this has missing dependencies, which this array here is called the dependency array. And the reason why useEffect can be like all of the other lifecycle functions is that whatever we put in here, or we'll only run this function that we've defined here, if the things in this array have changed since the last time it ran this component or rendered the component. So we don't want it to ever rerun. We just want it to run once when the component is mounted, which it does by default, and then set this interval and never have to worry about it again. But what React wants you to do is it sees that you use this state variable here and this like set state variable, so it wants you to put these in here like this to stop it from having a warning. But we don't want it to rerun every time count runs because then it'll set a new interval every time count changes. So every time this runs, it'll cause this to happen again and it'll crash because he'll hit too many intervals currently active. So we just do this, and usually you tell React to ignore this. Since it has good tooling, you can just disable the error for this line, and then you won't have that warning anymore in your project. And like I said before, if you were actually going to use this, you'd want to clean up this interval when you're done. Which I'm not going to go into how to do that now, just something you need to consider in the future. And that's basically all you really need for a component, and then it'll return this. Goes up to app gets returned all the way up to index. And so even if we had two of these counters at the same time, if we were to an app here and we just copy pasted this a couple times like this, and it's mad because it wants to have like a div as a parent. So if we were to do this, all of these counters would actually be separate. This state variable is not linked between them at all. These are all just reusable parts. And we could, import this counter in some other file, in some page, like if we're YouTube and we wanted the little like number that says how far into the video you are, we could use a counter for that. And if we wanted the subscriber count to be a counter as well, you could use it there. Like really you're limited to your own imagination here. And the fact of there being component kits makes it really easy to build nice looking websites really easily. So I think I'll end the example here and see if anyone has any more questions. I'm not sure why this doesn't work, but I think we're planning on making our website public. So if I go here to our website, wrong thing. So if we go in here, I can find that file I was just talking about. Components, and here's the loader that I copy pasted. Our meetings page, you can see it gets quite a bit more complex, but once you get used to it, this actually isn't that bad for you. You can see we use that same use state pattern here. We use a use effect with just a function. This is the part that gets your user if you're logged in. And down here we actually have our HTML that's getting returned. See our different components that we're using. So even though this seems complex, you can break it down into its simpler parts and kind of see what it's doing. So yeah, I think that's where I'll end it if no one has any questions. I guess I'll call it there. So thanks for coming. Next week we're going to probably not have a meeting because it's the practice or the qualifier for ACM. If you guys want to sign up for ACM still, you can. You just won't get a free t-shirt. Yeah, was that good enough for you once you could see it?